Welcome to this demonstration of using the Autodesk Nastran InCAD solver embedded in Inventor. This technology enables designers the ability to solve problems that go beyond the capabilities of linear static and frequency studies that are currently available in Inventor Professional. Using this hedge trimmer assembly, we'll focus our attention on the nonlinear options available for the material library as well as the solver. The guard on the hedge trimmer is made of thin plastic. Typical load conditions on the part cause a large amount of displacement. Linear static studies may provide designers with the highest stress location or displacement in the design. However, in order to gain high-fidelity results, the nonlinear static study is required in cases such as this. Here you can see we have the entire hedge trimmer assembly open in Inventor. We'll turn off the other parts and focus on the guard. Let's begin by starting a new analysis. There are several options available for different types. There are static and dynamic loading conditions for linear and nonlinear material. The material library for the study can be selected from a standard library or imported directly from the CAD model. In this case, we only want to analyze one of the parts in the assembly, so we'll select the guard and confirm the material we want to use. Autodesk Nastran provides a wide variety of material models to choose from. Here we'll use an isotropic material using a nonlinear stress-strain curve. You can see here we have settings for nonlinear elastic and elastoplastic for analyzing the behavior prior to yield. We'll use a simple two-point curve to define the behavior of the material. Inside this dialog, there is an option to check the curve for a quick visual overview. Notice that the material softens greatly after it reaches its yield point. Next, we'll apply some boundary conditions. The guard is going to be constrained at the base, so it doesn't move from the body of the trimmer. And we'll also apply a load to the front face of the guard for simulating a collision with an object. We'll use a value of 333 newtons, or about 75 pounds. Before running the study, we'll mesh the part or divide the geometry into several pieces to be analyzed. The real power behind running a nonlinear analysis is the solver. Taking a look at the setup, you'll notice an option to define the number of iterations. The solver will apply the 333 newton load in increments and update the stiffness of the model along the way. This is more accurate than linear static studies, which apply the load in one increment without updating the model stiffness. We can already see that the highest stress in the model is getting close to yield even before the solution is complete. There are many options available for results. The display plot will help us to determine how far the guard is deflecting. We can view the results at any point during the load. This may come in handy when applying a variable force that is loaded and unloaded. Here's a view of the displacement plot at 10 times the actual deformation. Let's take a look at a couple other result types. The von Mises plot shows us where we have areas of high stress. Notice that the highest stress is 43 megapascals, which is beyond yield. There is a good chance the guard will not bounce back to its original position after the load is removed. Each time a new study is run, there are countless hours that are saved as opposed to manufacturing a physical prototype. Using Autodesk Nastran in Inventor helped us to ensure the safety of the hedge trimmer assembly. We can now confidently move on to innovation in other areas of the design.